By now, you might have heard plenty about RAG agents and vector databases. In this video, I'll explain the concept of vector database and why it's so effective for AI agents, all with minimal technical jargons. I'll also guide you step by step on how to set up a vector database and plug it into n8n, all with no code, so that by the end of it, you'll be able to set this up yourself. Let's dive right in. So before we dive right into the workflow, I just want to take a minute to describe what vector database is in a very simple manner. And if you already know what vector database is and you want to jump straight into how to set it up on your n8n workflow, feel free to skip right ahead, but this is just going to take a minute. So a vector database essentially is different from a traditional database, which is maybe like your SQL database, Excel sheet, or Google sheet. It is great at finding exact matches. So what it means is, to take a very easy example, if you have a value, which is an apple, for example, it's not going to automatically categorize it to a category of a fruit, because it's only finding the exact matches for something. Meanwhile, the way AI works with data is that they extract semantic meanings from the group of words. That's why they're so flexible and effective and are able to adapt to different kinds of questions, even if it's asked differently. So a vector database basically stores the meaning instead of the actual data or the actual words. So for example, an apple or banana would be easily categorized into the category of fruits in the vector database format. And if you do a quick Google search of what vector database is, it's going to tell you that it's a multi-dimensional database with mathematical representation, which is not very intuitive to most people. But an easy way to think about it is that you have these blobs of words and meanings that are spread out into multi-dimensional space. And it is essentially the most effective way or the most efficient way for the AI to go into this vectorized data format to grab the blob of meaning. So in the example earlier, we talked about fruits, like apples and banana being categorized as fruits. It's going to live somewhere in the vicinity of that space within the vector. And how vector works is it converts text or images or audio inputs, which is in the raw format of the data that comes in, into numbers, and it's called embeddings. So for example, in a traditional database, you might be able to ask, hey, what's the best seafood restaurant around the area? And they wouldn't return to you restaurants that doesn't have seafood in its name, because that's the exact word they're searching for. However, in a vector database, it will return to you the highly rated crab or fish and chips restaurant around your area, because it knows the meaning of crab and fish can be categorized or very similar to seafood. And that helps a lot in an AI workflow, or just how generally AI works in retrieving data. So now going back into workflow, we're going to build from scratch a workload that is triggered by a Google Drive upload, so that any team members or anyone that you work with can upload any types of file in the folder and essentially send that to a vector database store, which will later on be chunked and embedded into a vector database we call Pinecone. And of course, Pinecone vector database is just one of the many providers out there that you can use. Supabase is another popular one, but they all work almost the same way. And today we're just going to run through Pinecone, and that should be a good way to start. So the first node you want to hit here is the Drive node, which is a Google Drive. And what we want to do is select on changes involving a specific folder, because we want to watch for any upload to that particular folder. So in this case, we're going to pick a folder called Pinecone DB folder. And here's a folder that I've created. It has nothing inside. And back to my workflow, essentially we want to pick file created. Right, so it's going to watch for any file created, which means file uploaded to. And it's going to run at every minute. So if you upload a file, well, within a minute, it's going to be able to read and trigger the events and the rest of the workflow. And before I hit test event, I'm going to go back to the folder and I'm going to upload a HR policy guidebook for ABC company, which is a fictitious company, which is incidentally the same document that I used in my HR policy RAG agent in my last video. So, check that out. I'll link it up here and in the description below if you want to create a simple RAG agent that refers to a Google Doc document. So this is what the PDF looks like. It's just a policy guidebook, and it has some essential information about working hours and leave policies, etc., right? Cool, so now I've uploaded that. I'm gonna go back to my workflow now, and I'm gonna hit test event. And there you go, as you can see, it's reading the uploads, and there's an output here. So we're good to go to the next node. Now after the first node, the next node that we wanna hit is really a download file node, because we wanna be able to download that file in binary format so we can pass it to Pinecone vector database. However, before we do that, we're going to think a little bit about what happens if we were to upload multiple files into this folder, right? So the trigger is only a singular trigger, so it's only going to run for the latest file that has been uploaded. It doesn't matter if you upload 5 files at the same time. It's going to read the latest file that's been uploaded and it's going to ignore the other 4. So what we want to do in that scenario is we want to add a loop over items node. And what this does is it basically loops over the node in the case when there are multiple outputs or multiple files from the previous node. So in this case, we want to set the batch size as 1 because that's the number of files that's going to be looped over every time. So this just ensures that if we were to upload multiple files, that it's going to read and it's going to run all those files and upload it one at a time. So I'm just going to delete this node here because really what I want to introduce is the Google Drive download file. So that's the node that I want to hit, and we want to connect the loop over to the download file here. Sorry, let me run that node one time so that's going to actually populate and we're going to be able to see the information here. So with the Google download file, the file that we're interested in, we can actually paste it either by URL or by ID, and both of them work. But in this case, I'm going to pick by URL, and we're going to scroll down to the web view link, and we're going to drag that and drop it right here. All right. So we're going to run execute step. As you can see, it's going to output the data in binary format. And we're going to just hit download. We know that the title is correct. I just want to double check that it's the right document. Yep, it is. So we're good to go there. All right. So we've now downloaded the file in binary format. And what we want to do next is now it's ready to be uploaded or upserted to the Pinecone vector database. So go over to pinecone.io. And what you want to do is hit sign up. And it's a pretty easy way to get signed up. You can sign up directly with Google account or with an email. I find it's easy to just sign up with a Google account, so that's what I'm going to do. There we go. And it's a pretty easy one-step SSO sign up. And there we go. I'm going to just first name, last name, purpose of business, purpose of use. I'm just going to hit personal. You can choose Python, or you can actually, I didn't see that, you can actually choose I don't code, and we're going to hit continue. So use case, RAG, what does your data look like? I have raw documents. What is your goal? Let's say evaluate Pinecone's performance, and we're going to get started here, right? So here we've got an API key generated. So what we want to do is just copy that, and we're going to go back to our workflow. And here, we're going to introduce a Pinecone vector store node. And in this case, we want to add documents to vector store. So here in the node, you see that I already have an account connected, but I'm going to create a new account here just so you guys can see how that's done. So that's account number 2. I'm going to leave it as that. I'm going to paste the API key here. I'm going to hit save. All right, so as you can see, the green bar shows up and it's all connected. So we're good to go there. Operation, we're going to stick with insert documents, which is what we chose. And the index, right now we don't have any index, so it'll be blank. And what we want to do is go back to Pinecone vector database. Essentially, what we want to do is to hit create an index, right? So we're going to come up with an index name. So in this case, we're going to do policy, or rather HR policies. So this is the index for all HR policies to go into that. But of course, you can have this as a company name as well if you want to just dump the whole chunk of company information in it. But then maybe you want to set up some namespaces and stuff like that for those things. But we don't have to get into the weeds of that. That's completely optional. But under configuration, what we want to do is we could choose any of these models. But what I'm going to choose here is a text embedding 3 small. The reason for that is it's easy to set up, but it's also is the most cost-effective embedding model. So I'm going to choose that. And before I move on, I want to make sure that I'm picking the right dimension here. By default, it says 512, but what we really want to choose here is 1536 because that will be the dimension that the node from n to n is going to output in. So you can think of dimension as basically a mathematical representation of the number of layers of the data, right? So, and without getting into the weeds of the technicalities, essentially you want to make sure that the output dimension and the vector database dimension that you're trying to upsert into is exactly the same. Otherwise, it's just not going to work. It's going to error out on your node, right? So let's scroll further down. We're going to pick serverless here, cloud provider. These are the big 3 cloud providers, and we're just going to choose AWS in here. Region, we're going to pick US East 1, and we're going to hit create index. All right, cool. Now that's created, we're going to go back to our workflow, and let's toggle out, toggle back in, and see if it shows up. And there we go, HR-policies, which is our index name. All right, so there's an embedding batch size here. So it depends on the number of documents that you're uploading. But in this case, because we're looping over just one document every time, the batch size is really just going to be 1, right? So it doesn't need to be 200 here. I'm just going to pick 1. And under embedding, And what are embeddings? Like we covered earlier, embeddings is basically trying to convert whatever format, whether that's image, text, audio that comes in into a numerical vector embeddings format. It's basically just changing all of that into numbers. So there are a couple embedding models that we can use here, but in this case, we're going to use embeddings OpenAI. I'm going to pick the right account, and under model, we want to choose the same model that we have in the Pinecone vector database, which is text embedding 3 small, and we're going to leave it as that. And then under document, loaders. So the default data loader handles loading and preparing your input data like PDFs or JSON. Basically, it gets it ready for processing by a vector data store, and it supports some key function as well, like the character splitter. So we're going to get into that in a little bit. So we're going to pick the default data loader here, and type of data is going to be binary, right? Because that's the binary data that we've received. And we're going to choose load all input data. And we're going to also choose, in terms of data format, automatically detect by MIME type. So it just means that it's going to automatically detect what type of data is coming in, and we'll treat it accordingly. And text splitting, we can leave it as simple. And what that does is it's going to let it decide the chunking of the data. And what chunking basically is the way that the data blob is going to be split. So for example, in this case, it's receiving a data blob, which is the HR policy guidebook, which contains all the HR policies. So that's a huge blob. So it's going to decide how it's going to split those blobs into smaller digestible blobs. They're easy for the vector database to store, but also for the AI to retrieve later on. So if you leave this part as simple, and it then is going to decide it for you, and usually that means it's going to split it to 1,000 per character with 200 characters overlap, right? In this case, I'm going to show you just simply how we can custom this. As you can see, it says 1,000 characters with 200 character overlap. So we're going to hit custom, and we're going to add a text splitter. In this case, we're going to choose recursive character text splitter. And here you can actually determine the chunk size. So it depends on how granular you want it to be in terms of the AI going over your data. So in this case, we do 600 and chunk size of 100, let's say. And again, there's no exact right answer on what kind of chunk size and chunk overlaps. It really depends on the type of documents that you're uploading. But as a general rule of thumb, 1,200 overlap is good. 600, 100 overlap is also pretty good. So in this case, we're going to stick with this. And it looks like we're all set up here. So we're going to just run this node. As you can see, it's embedding it multiple times. So it's telling you how many embeddings that it's doing. And there's an output of 11 items. And if we open that out and check out the output logs, we can see that it's doing that 11 times. And let's go back to our Pinecone vector database under the index and see how many items were passed. As you can see, the record count here is 11. So we have 11 items, 11 chunks or blobs of characters that are being uploaded into the index. And if you want to be granular about it, you can see the chunks that are coming into here. So as you can see, this is about employer benefits, and here, career growth. So it's actually chunking it very logically, right? So there's a logic in the way that they're chunking it. That's why it takes a while. They are open communication and feedback. Great. So let's go back to our workflow. So this is done. And I also realized that I've looped this wrong way. So I'm looping this over this particular node here, which is not supposed to happen. So what I want to happen is actually to loop it over from the download file node, because right now it's just looping over itself. So obviously that's not what we want. We want it to actually loop the download file node so that the download file will be part of each batch of the file that's been uploaded. So it's going to download it as well before passing it to the Pinecone vector store. So this is the right way to loop it. And before I do another test run, uploading all these files, I want to point out that in the test run, you're always going to run just one file, even though you're uploading multiple files. So what we want to do here is to toggle this to production, which means we're making it live, and then upload multiple files to see how it's treating that. So I'm going to hit save here, and I'm going to toggle this to on. All right. And then I'm going to go back to the folder, and this time I'm going to upload 2 files, which is the ABC Company Customer FAQ, as well as the ABC Marketing Agency project updates, which is in line with some of the company documents. And again, the index says HR policy, so you probably don't want to be uploading these documents to that particular index. But in this case, I'm just running the example so you can see how it's all working together. But okay, going back to the workflow, you're not going to see anything right now because this is in editor mode. So what we want to do is we want to go to executions, and as you can see, there's an execution running. So it is receiving the trigger and it's running the workflow, it's just not showing it. So we're going to wait a little while. All right, so it ran for 14 seconds. So as you can see, it actually looped over the download file twice, and you can take a look at the download file node. So you can see actually it's downloading the company customer FAQ, which is what we wanted, and also the project updates, which I've uploaded, right? So this is looped over twice, and then it goes to the Pinecone vector twice as well. So both of these documents are being uploaded, embedded, chunked, and it's all in the index now. So if we were to go over to the index, again, the index probably shouldn't have been called HR policies. Now the count has increased by a lot, and it's got a lot more than just the HR policy guidebook. And now that we've seen it's able to upload multiple files at a go, we know that we can open the Google Drive to our team members for them to upload multiple files, different formats, so on and so forth. So what we want to do now is to create a simple RAG agent to go into the Pinecone vector database to extract the relevant information in responding to us, right? So we're going to start with a simple chat trigger, all right? We're just going to populate that with a simple hello, all right? And we're going to introduce the AI agent node. We're going to use that chat trigger, and we're going to add a system prompt. Your helpful assistant, refer to the attached Pinecone vector data store to respond to user queries. All right. So we're going to just do a simple system prompt message there. Of course, you can do a lot more prompt engineering. And then I'm going to attach the OpenAI chat model here, OpenAI account 2. And in this case, we're just going to use 4.1 mini. On the memory, we'll pick simple memory. We're going to give it a 15 context window length just to give it a bit more breadth. And then we're going to then attach the Pinecone vector store node and choose the correct credential, which is the Pinecone API account 2. Retrieve document as tool for AI agent, and description-wise, we're going to say refer to this Pinecone, refer to this vector DB to answer user queries accurately. Okay, let's just do that. So under Pinecone index, as you can see, there's one index, which is the HR-policies. We're going to choose that. And then limit basically is just how many top results that it's going to fetch from the vector store. So we're going to just leave it as 4. Include metadata, we can leave it toggled on just to include any metadata that's attached to the documents or the blobs of the data. And re-rank results is actually a very useful one when we're talking about a huge amount of data, right? But in this case, because we only have 3 documents, it's not necessary for us. So we're just going to choose embeddings, and we have the embeddings, which is an OpenAI embeddings. Again, we want to choose the right account as well as the text-embedding 3-small. So that's the embeddings there. So that's the simple RAG AI agent with a Pinecone vector store DB attached. And we're just going to run this particular node. It shouldn't be touching the Pinecone vector store just yet because I'm only saying hello. So it says, hello, how can I assist you today? All right, so I'm going to ask it something relevant to the documents, right? So part of the documents was the project updates, for example. So I'm going to ask, what's happening with the AI caption generator pilot? All right, so let's ask it that. What's happening with the AI caption generator pilot? All right, so I'm asking it that. It's going into the Pinecone vector store. It's fetching the information. So it's only gone there once. So let's see the output. The AI caption generator pilot involved testing GPT power, Early findings showed the AI written caption scored 17% higher click-through rates, which is exactly what we said here. Early findings, AI written captions scored 17% higher click-through rates. All right, so let's ask it another question from the other document, which is the customer FAQ document. So you can see it's a pretty simple document. So I'm going to ask, who are our typical clients, for example? Who are ABC's typical clients? All right, again, it's hitting the agent. It's going into the vector DB, and full service marketing services such as digital campaigns, they work with clients globally, equipped with it. All right, so where is it getting this answer? You can actually open that node up and look at the output logs. So as you can see, these are the top 4 results that are coming out from the vector DB. It comes from the ABC company-customer FAQ, which is available here. And basically that's where it's getting the answer from. Cool, all right, so that's a simple build for a simple RAG AI agent with Pinecone vector database attached, as well as how to upload it with the Google Drive as a trigger. I hope this build was helpful in introducing you to the concept of vector database and how to use it within n8n. And I'll be sharing both of the free workflow templates down below, which you can download and use. So if you're having any trouble in any part of the builds, please let me know. Comment down below if you have any questions or just any comments in general. But if you like the content, as always, please consider subscribing, and I'll see you in the next one.